Hello class, today what we're going to talk about is Introduction to Probability. It's not so much an introduction since y'all have all had probability in junior high, middle school, whatever. This is going to be a refresher because you haven't had it in a few years. So, first off, a couple definitions. A probability is a trial that could have different results. You could have a 1, you could have a 2, you could have blue, red, whatever. Alright? And all those different results are called outcomes. So, for example, when you roll a die, you could have a 1, that's an outcome. You could get a 2, that's an outcome. A collection of outcomes is called an event. So, if you're looking for an odd number, that's an event. It could be one. You got several different things that could make that event up. Now, the set of all the possible outcomes is called sample space. That's all sample space is. It's just a list of all your outcomes. So here, if we're going to flip a coin and roll a 6-sided dice, how many possible outcomes are there in the sample space? We want to list out the sample space. Okay. So a couple ways to do this. We could just start listing out. We could get a heads with a 1, a heads with a 2, a tails with a 5. Could just list them out. But if you do it like that, a lot of the times you will miss one, or you'll count one twice, or things like that. Especially if it's real complicated, you got lots of different things happening. So a tree diagram is good because it makes sure that you get everything, but you don't count anything twice. Okay. So, for example, you got the coin flip. Could be heads, could be tails. If it's heads, when you roll the dice, you could have a 1 through a 6. If it's tails, you're going to roll the dice and you could get 1 through 6. So here we see all our possible outcomes. Heads with a 1, heads with a 2, heads with a 3, tails with a 4, tails with a 5, tails with a 2, tails with a 6, right? And so there they are. And down here at the bottom, this is how many total possibilities we have. We have 6 possibilities with heads, 6 possibilities with tails. So we've got a total of 12 possible outcomes, and here they're all listed. This right here is the sample space. All right, heads in a 1, heads in a 2, heads in a 3. That's the sample space. Okay. So what I want you to do is pause the video, list out the sample space for these two trials here, these two things, and come back and check your work. All right, so you're back. Let's see how you did. If you're flipping 2 coins, you could have a heads and a tails, tails and a heads, or 2 tails. Notice these are 2 separate things. This is heads on the first coin, tails on the second. This is tails on the first coin, heads on the second. 2 different outcomes. All right, and you see we have a total of 4 outcomes. Over here, we're going to flip 2 coins and then roll a dice. So here's all of them listed out. I'm just using H for heads and T for tails instead of writing it all out. There's a lot of them there, right? 24 total possibilities. And you can see when you're writing it like this how it's easy to miss one, or easy to think you've already written one down when you haven't, or to think you haven't written one down when you have, which is why the tree diagram is good. So we have 2 coins. So the first coin could be heads, could be tails. The second coin, well, if we've got heads for the first one, the second coin could be heads, it could be tails. The second coin, if we got tails for the first one, could be heads, could be tails. And then for each of those, we could have 1 through 6 on the dice. All right? And also this way, so you see, okay, we've got 6 outcomes here, 6 outcomes there, 6 here, 6 there. Looking at this bottom row, so that's a total of 24 possible outcomes. All right? Now, if you'll notice, the number of total outcomes for this compound event, it's called compound because you have 1 thing happening, 2 things happening, 3 things happening, right? More than 1 thing happening. The number of outcomes is equal to the product of the outcomes for each of the simple event. So for the first coin, I had 2 outcomes. All right? For the second coin, I have 2 outcomes. So that's 2 times 2 is 4. Then we have the dice, which has 6 outcomes. So 4 times 6, which is 24 total outcomes. Here we have 2 coins that could each be heads or tails. So 2 times 2 is 4 outcomes. All right? So let's take a look at probability. Probability is just the measure that something is going to happen, the likelihood. It's going to always be from 0 to 1 every time. All right? 0 means it's impossible. Odds of probability of rolling a 7 on a 6-sided dice. Not happening. 0. All right? A 1 means it is certain. It is going to happen every single time. Odds of getting a positive number on a 6-sided dice. They're all positive numbers, so that's always going to happen. 100%. And you can write these as either fractions, decimals, or percents. Probability could be any of those. Now, theoretical probability, this is the probability that something's going to happen, and you haven't actually done it yet, okay? In theory, you should get ahead half the time on a coin, right? And the way you find probability, theoretical probability, is the total number of favorable outcomes, what you're looking for, heads, right, over the total number of possible outcomes, heads or tails. Two possible outcomes, one of them is good, so it's 1 over 2. Right? And we write this as the probability of A. That's how this is. Probability of A, whatever A is. So it could be probability of heads, probability of rolling a 2, probability of an odd number. Right? P of whatever. So what we want to do here, we have a student taking a quiz, randomly guessing on the answers for 4 true-false questions. Not even reading the question, just putting down an answer. All right? What's the probability that they guess exactly 2 answers correct? So we're going to list our sample space. Now, how many are in the sample space? Well, you got 4 questions. Each one has 2 possible outcomes, right or wrong, right? So we got 2 outcomes here, 2 outcomes here, 2 outcomes here, 2 outcomes here. 2 times 2 times 2 times 2 is 16. So we have 16 total possible outcomes. We need to know how many of those are favorable. And favorable in this case is exactly 2, because that's what we're looking for. Exactly 2 answers correct. So we can list them all out. Get them all wrong, get the first one wrong, the next one's right, get the first one wrong, the second one right, the next 2 wrong, and so on. All right? So possible outcomes where we have 2 answers correct. We have 1, 2, 3, 4, 5, 6. So we have 6 favorable outcomes over 16 total outcomes. We have 6 over 16 favorable over total. Simplify that, of course, so it's 3/8. Now, it makes a little bit more sense if you change it to a decimal, or even better as a percent, and that is 37.5% chance of getting a 50. All right, now, real quickly, if you'll notice, okay, 70 is passing. To get a 70 on a 4-question test, you have to have 3 or 4 correct. So that's 1, 2, 3, 4, 5. 5 out of 16, not very good odds. Don't just guess, read the questions at least, right? Better chance of passing that way. Now, probability of the complement of an event. Okay, the complement of an event is not the event. So, for example, in the one before where we were looking at the event is getting a 50, the complement of the event is not getting a 50. Get a 25, get a 0, get a 75, get a 100. Anything is fine as long as it's not a 50. Okay? So this is how we write it. Probability of the complement of A. Probability of not A. Right? Also read as A bar, because it's got a bar over the A. Right? And what this is, it's going to be 1 minus the probability of A. All right? That's it, because 100% is everything, and you take A out, and you're left with not A. So here we have 2 6-sided dice. Going to roll them both. It lists our sample space for us right here. 36 possible outcomes, right? 6 for the first dice, 6 for the second dice. 6 times 6 is 36. Okay, we want to know the probability of getting the sum not being 6. So they can add up to 2, they could add up to 12, they can add up to anything they want as long as they're not 6. Now, we could add up all the ones that aren't 6. 1, let's see, there's a 2, there's a 3, there's a 4, there's a 5, right? Or we could just find the 6's, right? There's a 6 plus 6 equals 6 equals 6 equals 6. So we have 1, 2, 3, 4, 5 that equals 6. That's it. So the probability of not having a sum of 6, what we do is 1 minus 5 out of 36. Because 5 out of 36 is 6. We don't want those, so we take those out. It leaves us with 31 out of 36, which is a probability of 0.861, or 86.1%. Okay, here, the sum of the 2 digits is less than or equal to 9. Well, there's a lot of them that add up to less than or equal to 9, right? How many of them add up to more than 9? So we just want stuff that adds up to 10, 11, and 12. Well, if we look here, let's see, 9, there's a 10, there's a 10, there's a 10, those two are 11, that one's a 12, so we have 6 that add up to more than 9. So we want the probability of not those, right? So 6 add up to more than 9, so 6 over 36, we want 1 minus 6/36, gives us 30 over 36, which simplifies down to 5/6, which is approximately 0.833, repeating 3. So about 83.3%. Okay, so you can see how finding the complement makes it a lot easier. sometimes. What we have here, we have a dartboard, and we'll assume you're not very good at darts, but you're better than me because you are going to hit the board every single time, but you're equally likely to hit each place on the board. All right? You want the probability, you want to know, is it more likely to get a 10 than it is to get a 0? So these corner pieces. So we're going to compare the probability of getting the bullseye to the probability of not landing in the circle, but landing on the board. We need to know where those two probabilities are, right? So, probability of landing in the circle. What this is a question about is area. Okay, we have all of these points are good, so we're looking at the area in the circle compared to the area of the entire board. So favorable is area in the circle, the small circle. Total is the entire board. So pi r squared, r is 3. And the length of the board, it's a square. So area of the board is side squared. And you see this is 3 plus 3 plus 3 is 9 for our radius. So the diameter is 18. And that's both ways. So it's 18 by 18, 18 squared. So we have 9 pi over 324, which simplifies to pi over 36, which is approximately 0.0873. Now we need the odds, the area of the 0 spaces, right? Just the corners. So we need the area of the board minus the circle, minus the target spaces. So area of the outside the larger circle divided by the area of the total board. This is our favorable. This is what we're looking for. Right? So that's the board minus the circle, which is pi r squared. Pi or 9 is the radius. So we work that out. Still have 18 squared for the area of this board. Simplifies down, and we have an area, a probability of 0.215. So this is the probability of getting 0 points. Here's a probability of getting 10 points, and we see you're more likely to get 0 points than you are to get 10 points. If you're guaranteed to hit the board, but you have no clue where it's going to hit. All right? Okay, so what I want you to do is answer these questions here. Pause the video, work these out, then come back and check your work. All right, let's see how you did. So you're flipping a coin and rolling a 6-sided dice. We want to get a tails on the coin and a 4 on the dice. Only one way that can happen is a tails and a 4, right? So we have one favorable event over the total number of events, right? Total number of outcomes. Well, let's see, a coin has 2 outcomes. The dice has 6 outcomes, so that's 2 times 6 is 12. So 1/12. One good one over 12 total ones. All right, on these next 4, it wants us to find the probability of A, or the probability of not A. So we have the probability A is 0.45. We want not A, so it's 1 minus 0.45, which is 0.55. Here, we want the probability of not A. A is 1/4, so 1 minus 1/4 is 3/4. 1 minus 1 is 0, and 1 minus 0.03 is 0.97. And you could have these as percents, and that would be fine too. All right, here we want the likelihood of getting 10 or 5. Which one's more likely? Well, we already know 10. We found that already. So now we need to know what's the likelihood of getting 5 points, right? So here's 10. We found that on the previous slide. Likelihood of getting 5 points, well, that's the area of this circle minus the 10-point circle. So pi 6 squared minus pi 3 squared. So that's 27 pi over 324, which is the area of the board. We already found that. So the area, the probability is 5 points is 0.2618 approximately. So which one's more? Yeah, you're more likely to get 5 points. Okay. Now, are you more likely to get some points or more likely to get no points? Well, we could add this point probability and that probability and that probability, or we already found the probability of no points, right? And we want not 0 points. We want to get some points. So what we can do is say the probability of getting the points is equal to the probability of not getting 0 points. So 1 minus the probability of no points, which we already know is 0.215. 1 minus that is 0.785. And so, yeah, more likely to score points than to not score points. And this is basic probability. Hopefully that helps. I'll see you next time.